Hello everybody, welcome into another lesson. So today we are going to talk about graphing the cube root function. And this will actually serve for all odd power roots because the fifth root, the seventh root, what have you, is very similar to graphing the cube root. So here we have f of x equals the cube root of x. I am going to graph that in blue. So the domain for the cube root of x for any odd root is all real numbers. So there's no value of x you couldn't have. You can have the cube root of negative numbers and still get a real number. So that works for all of them. So let's start at 0. Well, when x is 0, cube root of 0 is 0, right? Okay. How about when x is 1? Cube root of 1 is 1, so you'll be at 1, 1. Now let's go all the way to 8. What's the cube root of 8? That's 2. So that'll put you over here at 8, 2. Now let's take x at negative 1. What's the cube root of negative 1? Well, that's going to be negative 1, right? So you'll get the point negative 1, negative 1. Now what about when x is negative 8? That's the cube root of negative 8 is negative 2. So that'll put you all the way over here. So now let's go ahead and graph this bad boy. And roughly, you're starting to see it. And there's your graph of f of x equals the cube root of x. You notice it almost looks like a tilted x to the third. It almost looks like a tilted f of x equals x to the third. Well, that's because essentially it is. Because the inverse function of f of x equals the cube root of x is in fact x to the third. In fact, let me write that. F inverse of x in this case would equal x to the third power. Now, I'm going to draw y equals x for a reason. So of course at 0, 0, you would have 1, 1. You would have then 2, 2, 3, 3. Negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, and so on. So let's go ahead and draw this here. Now, there's the y equals x. Now let's draw the inverse next to it here. I'm going to draw the inverse in red. So the x to the third power, well, 0 to the third is still 3, right? What's 1 to the third? Well, that's also 3. Now what's 2 to the third? That's going to be 8. Now what's negative 1 to the third? That's negative 1. Negative 2 to the third is going to be all the way down to negative 8. So let's go ahead and graph this. That's about. So what do you notice here? When you draw f of x equals the cube root of x and then f inverse of x equals x cubed. Again, since they're inverse functions, they are symmetric to the line y equals x. And that's true for any function and its inverse. They will always be graphically symmetric in the line y equals x. So that's kind of a cool thing to know about functions and their inverses if you go to graph them side by side. All right, let's talk about a reflection here. So let's say this time I'm going to do f of x equals the cube root of negative x. F of x equals the cube root of negative x. Well, when it was the square root of negative x, that reflected it in the y-axis, right? And it technically does with the cube root also, but what's different about a cube root or any odd power root? Isn't this the exact same as taking the cube root of negative 1 times the cube root of x? Now, what is the cube root of negative 1? Well, that's just negative 1, so in other words, you would get negative of the cube root of x. So with even power roots, if you had the negative sign outside of the radical, it reflected in the x-axis. Well, whenever you have a negative inside of a radical, if it's an odd power root, you can always extract a -1 and move it outside the radical. So actually, wherever you see the negative sign for an odd power root, whether it's inside or outside the radical, it's reflecting in both the x and y axis at the same time. Now let me show you. Let's graph f of x equals the cube root of -x, all right? So cube root of 0 is still 0. That hasn't changed. Now, all right, let's put in x as 1, +1, but you'll get the cube root of -1, so you'll be at the point 1, -1. Now let's put in 8 for x, right? So you get the cube root of -8, which would be -2. So that would put you at 8, -2. So let's draw this branch of the cube root function. All right, now let's put in -1 for x. You would end up getting the cube root of +1, which would just be 1. So you'd end up getting -1, 1. Let's put in -8 for x. You would end up getting the cube root of +8, which would end up being 2. So let's go ahead here. Let's draw the left branch of this function. And notice now, it's reflected in both not only the x, but the y-axis from where it was too. So if you have an odd power function, it's going to reflect in both the x and y-axis if you have a negative either inside or outside the radical. It doesn't matter. Now, for even powers, it does matter, but for odd powers, for odd roots, it doesn't matter. So that's something to keep in mind. Okay, let's move on here. Now, let's say we got something like half of the cube root of x. So I'm going to graph f of x equals half of the cube root of x. Well, this is true for all functions. If you have a coefficient outside of the radical, that represents, and if that coefficient is greater than 0 but less than 1, that represents a vertical shrink. So this is shrunk by a factor of 2. It's half of what the normal cube root of x is. So let's still put in x as 0. Well, half of the cube root of 0, that's still 0. All right, now, let's put in x being 1. Cube root of 1 is 1. What's half of 1? Well, that's 1/2. So you'll be at the coordinate 1, 1/2. Now let's put in x as 8. So what's the cube root of 8? Well, that's 2. Half of 2 is 1. So you'll only be up at 8, 1. Let's go ahead and draw the right branch of it. Now, let's take x as -1. What's the cube root of -1? Well, that's -1. Half of -1 is -1/2. That'll put you about right there at -1, -1/2. Now let's go all the way to x equals -8. What's the cube root of -8? Well, that's -2. Half of -2 is -1. So you'll be at the coordinate -8, -1. So let's go ahead and graph that here. So notice, it looks a little more flattened out. That's because it's a vertical shrink. It's not as tall. And remember, a vertical shrink affects the horizontal in the fact that when it's shrinking vertically, it's stretching horizontally. That's something else to keep in mind. All right. So there's that one. Now, what if I give you -2 times the cube root of x? So we're going to take -2 times the cube root of x. Well, the negative indicates a reflection here, right? We're definitely going to have a reflection in both axes, but that coefficient of 2, basically you take the absolute value of your coefficient, which would just be 2, right? If the coefficient is greater than 1, that represents a vertical stretch, which is also a horizontal shrink. So let's graph this. So cube root of 0 is 0. Negative 2 times 0 is 0. That hasn't changed. Now what about when x is 1? So cube root of 1 is 1 times negative 2 is negative 2. So you'll be at the point 1, negative 2. How about when x is 8? Well, the cube root of 8 is 2 times negative 2 is negative 4. So we'll go all the way to 8, negative 4. Let's go ahead and draw the right branch of this, which would be right there. Now, what about when x is negative 1? Cube root of negative 1 is negative 1 times negative 2 is actually positive 2. So you'll get negative 1, 2. Then how about when x is negative 8? So the cube root of negative 8 is negative 2 times negative 2 is positive 4. Let's go ahead now and draw the left branch of this. Alright, so as you can see, it's not only reflected, but it's stretched vertically. It's a little bit taller in each of the up and down directions, but it's shrunk horizontally. It's not as flattened out. So that's the graph of f of x equals negative 2 times the cube root of x. Okay. Now, good one. So we have the cube root of x minus 7. So we've been given the cube root of x minus 7. Notice that minus 7 is outside of the radical. Okay. Just like for a square root function or any function in general, if you just have the normal function, then plus or minus a number outside of the radical or the term, that indicates that it's a vertical shift up or down. In this case, that's a vertical shift down 7 units. So you're going to take your starting point and go down 7 units. Now, take what's inside of the radical, set it equal to 0. Well, x would equal 0, right? So you're going to shift the starting point down 7 units. So when you get the cube root of 0, that's 0 minus 7. That'll put you at 0, negative 7. 5, 6, 7. So you'll be all the way down here. All right, now let's put in x as 1. Cube root of 1 is what? That's going to be 1 minus 7 is negative 6. So you'll be at 1, negative 6. Okay. Now, what about when x is 8? Cube root of 8 is 2 minus 7 is negative 5. So 3, 4, 5. All right, let's go ahead and draw the y branch of this. Let's draw the right branch. Okay. And eventually, if you kept going in your x values, this would actually intercept the x-axis. It would be at a number which would be 7 to the 3rd power, which I believe, what is 7 to the 3rd power? 343. Your x-intercept wouldn't occur until 343, 0. So we definitely don't have that much space. Okay. Now, let's go to the left a little bit, the left branch. What's the cube root of negative 1? Well, that's negative 1 minus 7. That would actually put you at negative 1, negative 8. Okay. Now, what about when x is negative 8? Cube root of negative 8 is negative 2 minus 7 is negative 9. So you would be at the point negative 8, negative 9. Let's go ahead and draw the left branch of this. All right, so that's literally the graph of f of x equals the cube root of x shifted downward 7 units. So that's what you would get. All right. Let's go on to the next one. Here is, so we have the cube root of x plus 3/4. So we've been given f of x equals the cube root of x plus 3/4. Well, that 3/4 is outside of the radical sign, so what does that mean? You're actually shifting everything upward by 3/4. Take what's in the radical, x equal to 0, that'll be your starting point. So when x is 0, cube root of 0 is 0, plus 3/4, you'd literally be at 0 3/4, which would be right about there. Okay, now what about when x is 1? Cube root of 1 is what? That's 1 plus 3/4, that puts you at 1 3/4, which would be right about there. Then when x is 8, cube root of 8 is 2 plus 3/4, that puts you at 2 3/4, which would be right about there. So let's draw the right branch of this. All right, now let's go to the left. When x is -1, cube root of -1 is -1. -1 plus 3/4 is, well, -1/4. So that's going to put you right about here. And then let's go all the way to x is -8. What's the cube root of -8? Well, that's -2 plus 3/4. So that'd be -1 1/4, which would put you right about here. So now go ahead and connect your curve. Of course, you would end up getting an x-intercept at the point x is equal to the cube root of -3/4. But we're not looking for that today. But as you see, this takes the curve of f of x equals the cube root of x, shifts everything upwards by 3/4 of a unit. All right. Now, what if we had this? We have the cube root of x minus 5. So this time you have a whole quantity inside of the cube root. Well, like with the square roots, if it's under the radical, plus or minus, that's a horizontal shift. So if you set x minus 5 equal to 0, you would get x equal to 5 being your starting point. So you would definitely have 5, 0, right? Because the cube root of 0 is 0, it would start at 5, 0. You just shifted everything to the right 0. You shifted everything to the right 5 units. Okay. Now, 1, 2, 3, 4, 5. Okay, I counted right. Let's go right a little bit more. So if I make x 6, what does that give me? 6 minus 5 is 1. Cube root of 1 is 1. So I'd be at 6, 1. And then somewhere over in here, I'm going to end up going up to 2. All right, let's do the left branch. What if I made x 4? Well, 4 minus 5 is -1. Cube root of -1 is -1. So I'll be at the point 4, -1. And then if I made, let's see, what if I made x -3? Well, -3 minus 5 is -8. Cube root of -8, that's going to be -2. So -3 would put you at, you'd be at -3, -2. So let's go ahead and connect this curve now. And it would just keep going on and on. But as you see, we've shifted everything to the right 5 units. So that's true for any function, even if it's like, say this were x minus 5, the quantity to the third power. The inverse function, well, or somewhat inverse, that wouldn't be the exact inverse, but it would shift it to the right 5 units. Or, I don't know, you had any other, like even just x plus 5, it shifts anything to the right 5 units. I mean, yeah, x minus 5 quantity squared. It would do the same thing. So that's a horizontal shift. Okay, now we also have the cube root of x plus 2/3. So under the radical sign, we have the cube root of x plus 2/3. Well, set x plus 2/3 equal to 0, you get the coordinate for your starting point at x equaling -2/3. So when x equals -2/3, you get a y value of 0. So negative 2/3, that's about right there. So what you're doing is you're taking everything, shifting it to the left by 2/3. Okay. So let's start at the right. If, let's see, let's say x is positive 1/3. Well, if x is positive 1/3, you add that to 2/3, you get 1. Cube root of 1 is 1. So when x is 1/3, you'll be at a y coordinate of 1. So 1/3 1 is a coordinate. Okay. Now let's see. 7 1/3 would be 22/3. So it's 7 1/3 plus 2/3, that's 8. Cube root of 8 is 2. So at 7 1/3, you'll be all the way at a y value of 2. So we can now draw the right branch of this graph. Okay, now let's see here. Let's go to the left. So x equals negative, all right, so negative 1, that would be, let's see. Trying to think backwards can be crazy sometimes. Let's see, x plus 2/3 equals negative 1. So x would equal negative 5/3. Okay, so that would end up being negative 1 2/3. So when x is negative 1 2/3, you get the cube root of negative 1, which would be negative 1. Negative 1 2/3 right there. And then let's set x plus 2/3 equal to negative 8, which would then give you that x would equal negative 26/3, which would end up being negative 8 2/3. You would end up getting negative 2 for your y coordinate. So that puts you about right there. So what we've done is we've taken this cube root function and we have shifted everything to the left 2/3 of a unit. I think I have about, what, 3 more? Not many more. All right. Yep, 3 more. Okay, so we have a 5th times the cube root of x minus 2 on the outside of the radical. So we have 1/5 of the cube root of x, all that minus 2. So this tells you a couple things. One, this is a vertical shrink by a factor of 5 because you have a fractional exponent that's less than 1. And number 2, it's going to shift everything downward 2 units since that minus 2 is outside of the radical. Your starting point, then just set x equal to 0, you'll get 0. Okay, so what's the cube root of 0? That's 0. 1/5 of 0 is 0. Minus 2 is negative 2. So you'll be at the point 0, negative 2. All right. Let's put in 1 for x. What's the cube root of 1? Well, that's 1. Okay, what's 1/5 times 1? That's 1/5 minus 10/5. That would end up being negative 9/5 or negative 1 4/5. So that would end up putting you about right here. And then let's put in 8 for x. What is the cube root of 8? Well, that's going to be 2. What's 2 times 1/5? That's 2/5 minus 10/5. That'd be negative 8/5 or negative 1 3/5. So that would put you about right there. So now let's go ahead and draw the right branch of this. All right, and then let's go to the left branch. What's the cube root of negative 1? Well, that's negative 1 times 1/5 is negative 1/5 minus 10/5, negative 11/5, so that'd be negative 2 1/5, which would be about right there. Okay. Let's put in negative 8 for x. Cube root of negative 8 is negative 2 times 1/5, negative 2/5 minus 10/5. That ended up being negative 12/5 or negative 2 2/5. So that would put you about right there. So let's go ahead and draw this. Oh, wow, that's terrible. That swings way out. We don't want to swing that far out. Good grief, no. I'm trying to illustrate a narrow function here. So look at that. Look how narrow that is, right? It's definitely vertically shrunk, not very tall, but that means it's horizontally stretched. It pretty much is almost flat at that point. It's horizontally stretched, and it's shifted downwards 2 units from the starting point. So those are things to note about transformations in the original graph, how we got from where we did from the original f of x equals the cube root of x. Alright, I have 2 more. What if we had, oh, good one. We have negative 3 times the cube root of x plus 4. So we've been given negative 3 times the cube root of x plus 4. That plus 4 is inside of the radical. So we got 3 things going on. From the original cube root of x, that negative sign tells you you're going to be reflecting the original in the x and y axis. What else? So that coefficient of 3, take the absolute value, this is a vertical stretch, which will make it vertically taller, but will shrink it horizontally. And then that x plus 4 under the radical, that's going to shift everything to the left 4 units. So x would start at negative 4, which means you would get negative 4, 0 for your intercept. So that's going to be right here where it starts. Okay, now let's say I'm going to start at the right. So if I take negative 3 for x, what's that? Well, that would give me cube root of 1, which is 1, times negative 3 would give me negative 3. So I'd actually end up getting negative 3, negative 3. Okay, now let's go all the way to x is 4. Well, when x is 4, you get the cube root of 8, which is 2. Negative 3 times 2 is negative 6. So 2, 3, 4, 5, 6. So look at this here, right? We're going to draw the right branch of this. Now let's start with the left branch. If x is negative 5, that gives you negative 5 plus 4. The cube root of negative 1 is negative 1 times negative 3 is positive 3. So actually at negative 5, you would end up going all the way up to positive 3. And then for the next number over here, you're off the charts. So let's do the best we can to draw that. Somewhere over here, you'll keep going up. But point is, not only is it shifted to the left 4 units, look how much vertically taller that is and horizontally shrunk that is. So it's amazing that, and the reflection also. So look at the original, compare that to the original cube root of x. Quite a transformation. And I got just one more. Oh, real good one. 2 times the cube root of x minus 4, that whole thing, plus 3. So we got 3 things going on with this one again. So f of x equals 2 times the cube root of the quantity of x minus 4, that 4 being underneath the radical. Then you have a plus 3 outside of the radical. So we got 3 things going on. This is going to be vertically stretched by a factor of 2, which means a horizontal shrink by a factor of 2. That 4 under the radical, you set x minus 4 equal to 0. you'll get the starting point 4, 0. So everything shifts to the right 4 units, but we also have that plus 3 outside of the radical, which means we're shifting everything upward 3 units. So those are the three things we have going on. But let's start when x is 4. 4 minus 4 is 0, cube root of 0 is 0, times 2 is 0, plus 3 is 3. So when x is 4, you'll end up getting the y coordinate of 3. So you start at 4, 3. All right, what about when x is 5? When x is 5, you end up getting 5 minus 4, which cube root of 1 is 1, times 2 is 2, plus 3 is 5. So you'll end up all the way at 5, 5. Let's start drawing the right branch here. You would eventually end up even higher. Now, let's go backwards. What about when x is 3? 3 minus 4 is negative 1. Cube root of negative 1 is negative 1. Times negative 2 is negative 2. Plus 3 is positive 1. So when x is 3, you'll be at positive 1. And then let's go all the way to negative 4. When x is negative 4, you end up getting the cube root of negative 8, which is negative 2 times 2 is negative 4 plus 3. That's going to end up being negative 1. So at negative 4, you get the y coordinate negative 1. So let's go ahead now and draw this here. So look how much, well, I probably should have, yeah, I mean, it's going to look a little bit stretched here, but the point is, look how much vertically stretched this is and horizontally shrunk it is, and then everything shifted to the right 4 units and up 3 units. So that's the transformation from the original cube root of x to what we have here. So that's it for graphing the cube root function. The next few lessons will be about solving rational exponent equations and radical equations. So I hope everyone has a great night. Take care.